So as you see, we've got these index numbers. So what we're going to want to do in the end is we're going to want to create some kind of visualization. Now, there's lots of different visualizations we can do, but I'm going to have one that is going to be essentially a unique identifier for every word that you're interested in this text. And one really good unique identifier is a barcode. So basically what we'll create is a rectangle that has lines that represent every entry of that word across the entire space of the text. And it will create essentially a barcode image for that word. And you can compare barcodes and visually see the distribution of different words. This probably isn't high-level corpus linguistics, but it gives you an idea of the kind of, if you can imagine it, you can create some kind of visualization of it. So the way we're going to do that is we're going to use a library called matplotlib. And we're going to use a very specific part of that library called Python plot or pyplot. So I would start as a new box here if you've not already, just so that we don't accidentally overwrite any of our information that we have previously. So here we're going to import a library, but rather than just import it directly through import, we're actually going to import just part of the library because the matplotlib library is actually very large. We only want part of it. So the way we do that is we say from matplotlib or lib import pyplot. Now we could just do that here, but in kind of a convention for people who use this library to abbreviate pyplot as PLT. So it's a little bit smaller, a little bit less text that you have to type over and over again. And you are going to be typing this a lot. You can abbreviate it as anything in the world that you like. But the standard convention is to abbreviate it PL as in Lima, T as in Tango. And so that's what I'm going to do here, just so that if you search for any kind of variation of this, you'll be able to find examples online because everyone uses this abbreviation. So what pyplot basically allows you to do is to create a graph. Now it can create any kind of graph. It can create bar graphs, scatter graphs, line graphs, or graphs and images of your own devising. It's very, very flexible. So on the one hand, the stuff that we're going to do today is like, well, I could just do that with Excel or with some other spreadsheet program. And that is true to an extent. We're going to do a fairly low level graph today, but the elements that you're going to learn about and the fact that you can have it iterate over a huge data set is much, much better than Excel. I don't know if anyone has used Excel for gigantic data sets, but it will freeze and it will die and it will never work again. Python's able to do it on this in a much faster way. So the first thing that we want to do is we want to create a graph. And the graph is going to be constantly added to until you tell Python to close it, to kind of finish it. So we have to be careful not to try to do too much at once. You can actually layer element after element on this graph bit by bit so you know what everything does. So the first thing we want to do is we want to create a graph. And I'm going to just call this, what we're basically saying is we're creating a figure. We're creating some kind of object that we're going to plot. So we're using the library PLT and the method figure. And there are lots of attributes that you can put inside of this, but we're going to do it like step by step instead of one giant line. So the only thing that we're going to do at the beginning is how big do you want it to be? Now, the sizes that you put in are going to be in inches. I apologize, that's just the way it is, US centrism. But what you can really do is think about what proportion you want your figure to be. What ratio do you want it to be? And Jupyter will scale it down to fit inside the window of your computer screen. but in terms of it in the computer, in the memory of the computer, it will be full size. So you won't lose any resolution if you happen to be working on a small screen computer right now. So I want to make this twice as long as it is tall. So 10 by 5, 10 being the x-axis, how long it is, how wide it is, and 5 being how tall it is, what the height of it is. Now, if I run that at the moment, it does not like it. Oh, I sorry. I forgot to tell it what it's doing with that number. So it's the figure size equals, and then 10 by 5 is in its own curved brackets. So there's a lot of brackets here. It's plot.figure, open bracket, fig size equals, open bracket, 10 by 5, close bracket, close bracket. This closes this, and this closes that. Now, if I run it, it says that I have an image that is 720 by 360, and it has no axes. I've not given it any kind of data yet. If I want to show the image, if I want it to actually show the image as an image, I can do PLT show. And then what I want to do is at any time I show the image, I also want to close the image. And the reason for that is that if I don't do that, if I try to make a new image after it, it'll just add those new elements onto my old graph. You want to kind of open it, do stuff, and then close it down so that it's not constantly overriding it. And when we do our work on tomorrow's session, the reason for this will be really obvious. So if I run it now, again, it doesn't do anything because it doesn't have any data display. All it can say is I've made space for an image that is going to be 720 by 360. So now we have to start to fill in our graph with some kind of data. So one of the easiest ways to kind of do this is to put in a scatter graph, a graph with just individual points in it. So the first one I'm going to do is PLT scatter. Now, if you don't like scatter graphs, you can also use bar or line. Works absolutely fine. But I'm going to use scatter for today. Now, a scatter graph at the very basic level has two elements: the x coordinate or coordinates and the y coordinate or y coordinates. So if I want to have a very simple graph of just 1, 1, I can do that. It will create that 1 point. And you can see here, it's created it at 1 and 1. Now, the problem with this graph is that it's got really weird tick marks. Those are sort of not what I would typically use. It's not to scale. Why is it starting at 0.98? There's all sorts of data presentation that is wrong with this graph. But Python doesn't know that. It's just trying to put the dot in the center, and that's the best it can do. If I wanted to do more than one dot that was the same color, I would add other things to these lists. So if I have another one that is at 2, 2, remember, everything here is a list of all the x coordinates. Here is a list of all the y or the height coordinates. And I run that. Now I have 2 points. I have my 1, 1, and I have my 2. And again, because I've got 2 points now, it's trying to make it as small as possible or as high resolution as possible and still contain those 2 points, which is why this is, starting at like 0.8 or, 0.99 and then going to just over 2. So it's sort of a strange axis, but it's trying to make the graph fit the data that you have for it. Now, if I don't want to have everything to be the same color or the same series of data, I can add a different set, And because these are two different lines, it will automatically make it the next available random color. So it will make it a different item. But this is still the same data. So let's change it to 3, 4, 3, 4. So now I've got my 2 blue points and I've got my 2 orange points. Now, if I didn't want this to be a scatter graph, let's say I wanted to change this to a bar graph. You can see here, it's taken the same data, but it's transformed how it displays it to me. So now it's just individual bars. Now the bars give you an idea of how we're going to go about and create our barcodes. So hopefully this is pretty simple so far, but let's do something about these axes, because this is just making the data scientist in my head really, really uncomfortable that it's starting at 0 over here, but not over here. And it's just, it doesn't look right. So create bars. Create. Okay, so there are 2 different parts of the axes that you want to create. You want to create the limits, so how big the axes should be, and also which tick marks, what numbers do you actually want to see. The first thing that we'll do is we'll create the limits, and these are hopefully pretty straightforward. The X limit is called .xlim, and the Y limit is called YLim. And all you have to do is put in 2 numbers, the first number you want on the axes and the last number. So I want this on the x-axis to go from 0 to 5, and I want the y to do the same thing, 0 to 5. And now if I run it, I get 0, 0, 5, 5, and it's a much nicer graph. This is exactly what I want it to do. This should be back 1, because it doesn't matter if the word is in the stop list or not to find out what number it is. Absolutely. Thank you for bringing that to my attention. That was a typographical error. I appreciate that. Yes, so we want for word and word, every time it goes by word, to increase that iterator, not just if it's not a stop word. Okay. The only thing I didn't really explain in here is that there's nothing in this particular system. All you're doing is drawing individual elements. So there's nothing in the system that says you can't combine different things. So I can make these scatter points. I can make these bar charts, and I can actually add a line as well. And if you do a line, it's slightly different because you just put in a list of numbers, and it'll do it across time. So if I do 6, 7, 5, 3, or yeah, 6 is good. And I do this. Oh, I apologize. That's not how you do it. And I'm getting 2 libraries confused. So we'll take the line out for now because that's a different library. But you can see I can put my scatter points as well as my bar chart as well. So there's nothing that says you have to do one or the other. Now, let's say I don't want this to be blue and orange. For example, in the digital humanities community, there is a disproportionate number of individuals with red, green color blindness. I'm not sure why that's happened, but it's something that I've noticed sort of anecdotally over the years. So I have to be very careful about what color schemes I use when I create my visualizations. Fortunately, there's absolutely nothing to stop you from choosing whatever colors you like here. So if I wanted to make my scatter chart color spelled the American way, black, make sure you make that a string, and color blue, I can choose the specific colors I want to do. Now, it's not just colors. You can also do patterns if you want to do it with stripes or you want to do it with hash marks. If you look up on Google, you can see all the different colors and all the different ways that you can do it. If you don't have a very basic color that you want to do, you are also able to put in hexacodes to make it, I guess, pink, and anything like that. So there's lots and lots of ways that you can choose exactly the color scheme that you want to use to create your thing. The other thing that we want to do is about the axes is we want to choose which tick numbers we have. So here it's done 0 through 5, evenly spaced. That's fine. But let's say we didn't want it evenly spaced. Let's say we wanted the Y ticks to only be these numbers. So I want it to show me 0, 2, 4, and 6. And the X ticks, I only want to see 1, 3, 5. And if I do this, I now get the exact tick marks that I want. This again can be very useful if you're doing something like a timeline where you want to put in, you know, January, February, March, as opposed to numerical ticks along the bottom, and you want it to go in a specific order. You have a huge amount of control here about what you should do. The other things that can make it just a little bit nicer is you can create a title for your chart. So PLT title, and hopefully this is all fairly intuitive. And in string, my chart. That creates a nice graphic for it. And PLT legend. And the legend is not going to be useful yet until we put up here. If you want to label these different parts of your graph, you can also just give them labels up here. So this I'm going to label A. And this I'm going to label 1. And then I want to show my legend. I want to put my legend in the upper right. You can do upper center, bottom left, anything like that. And then it creates a legend for my graph. So I know that was quite a lot of bits, but those are the elements that you might want to use. Now, what can you use this for? So for example, when I was doing a project on 19th century newspapers, I was able to get data on the number of inches, the sort of space, different articles in a page of a newspaper we're using. And I was able to feed those in, just pull them from the data and create a bar chart. I was able to squish the bars together very closely, make it a certain ratio. So it basically created the illusion of a newspaper page with different color items for each genre of article that I had pulled from this database. So I was able to make color-coded visualizations of the newspaper data based just on the word count of each individual article. So that's something that I tried for weeks to do with Excel, and I could never make it look right without having to go just into a paint program and like draw the thing manually. So you don't just have to do normal graphs, you can have it create an actual visualization of any kind of data that you have. Okay, so the next thing we want to do then is we are going to, and I'll just leave that here for now because it doesn't really matter if we keep it or not. We now want to get an idea of if we have a graph of our entire book, our entire dictionary, what we want to do is we want to know how many entries, how many different bits each of these is going to have. Now there's a very simple function that we can use to find out the length of all of these lists, and that is len. So len tells us how many items are in a list. And what I want to find out is I want to find out which which word in my entire dictionary has the most entries, which is the most commonly used word. Now, again, there are lots of different ways to do this, so I'm just going to take you through my thought process of one way that you can tell the computer how to do this. So we're going to create a new loop, and we're going to create a new iterator that we're going to call 1. And what we're going to do is we're going to go through every word and list, index list, in our dictionary. For those of you who haven't looped through a dictionary before, you can't just say for word in dictionary, you have to do it as a pair. So for every pair of word and list of indexes, and then you have to say it's in the items within your dictionary. So for every pair of word and indexes, I want you to see if the length of that index is greater than our current highest one. Now, our current highest one is 1, so that should get, overwritten pretty easily. But we want to see, is the current word that we're on have at least more than 1 entry? If it does, change the value of I. So change I to that new index number. So if we go to our dictionary, it'll go to produced, and it'll say there are 1, 2, 3, 4 entries in produced. Is 4 bigger than 1? Yes, 4 is bigger than 1. Change I to 4. Go to the next word. Anonymous, it has 4. It has 1 entry rather. Does anonymous is 1 bigger than 4? No, 1 is not bigger than 4. So just go on back to the next word. Don't change anything. And it'll just do that over and over again for the entire dictionary. Now we use I a lot, and we don't want to lose this number. So at the very end, going all the way back, no indents. So after it's done looping through, I want you to save the final count to whatever that last I is, and then print it. And if I run this, the word in my dictionary that has the most entries has 252 words. Sorry, 252 instances of that word in the entire group. Now, I can tell you right now, if we hadn't done the stop words, it would have been over 2,000 because of those stop words that get used a lot. But the substantive words, the one I have the most of is 252. So what am I going to do with that number? Well, now we're going to go backwards through our list from the biggest number to the smallest number, and we're going to look for the top 5 words. Why are we going to do that? Well, there are so many words in this that we can't graph them all. That would just take too long for us to read them afterwards. We wouldn't get anything useful out of it. So I just want to see the 5 most commonly done words. So how do we do that? Okay, we start again. We're going to make a list of our top 5 words. So these 5 words are going to get put into this list. It's just blank at the moment. We don't know what our top 5 words are, but we're just telling it, when you get a top word, I want you to stick it here. And we're going to start with our final count. Now, the reason I'm not just using the final count directly in the program is that we're going to count down from there. And if we count down, we'll lose what our final count originally was. So I want to save it as 2 different variables. And now we just do a simple while loop, a simple countdown loop to go through all the words and see which are the top 5. So while I is more than 0, go through every word index in the dictionary. Check to see if the index length is equal to I. So is it exactly the same as the number that you're currently on? If it is, remember, we're starting at number 252. So if it's got 252, and if the top 5 list is less than 5 words long, so as long as the top 5 list isn't already filled up with other words, then append that word to your top 5. So what this basically will do is it will go through all of the different words in that dictionary and see if it matches that highest word that we know we have, which is 252. Once it goes through and checks everyone for 252, it'll decrement I equals I minus 1, and it'll look for all the 251s, and then it'll look for all the 250s. Now, as you can already tell, this is fairly inefficient. There are simpler, faster ways of doing this, but I wanted you to understand the logic so that you can create your own thought processes and explain those steps to the computer that you want to take. Once it's gone through this whole list, I just want to print my top 5 words so I can see what they are. We run the code to see if there are any errors. There are not. And we can see that the top 5 words in the Tragedy of Pudd'nhead Wilson are said, which seems probably pretty obvious, Tom, won, now, and Wilson. So these are our top 5 words. Now what we want to do is we want to combine this information that these are our top 5 words and these are the counts that go with those top 5 words and create some kind of visualization. So here we go. This is going to take a lot of everything that we've already done, but let's try to do it together. So the first thing that we want to do is we want to create a graph. We want this graph to contain all of our information. So plot figure, big size equals, this time, yeah, we'll do it the same. We're going to keep it at 10 and 5. So it's going to be a long, short graph. We don't want it to be a square or anything like that because it's going to be a barcode. The next thing we want to do is we want to create a loop. If we go back and we look at our graph here, I had to type in each of these scatter points manually. And as I said before, if you're doing it manually, you're not doing it right. You want to do it with some kind of algorithm to populate everything for you. So what we want to do is we want to do a for loop. So for every word in top 5, so this is going to go through said, Tom, won, now, and Wilson. Now for each of those, I want to create a bar. And the bar is going to be like that. X, Y, label, and width. And let's talk through these things. So first of all, the label, I don't want to put in manually. I want the label to be the word that I'm doing. So I can just type in word. Word is a variable, so it'll just replace word with whatever word I'm on. And width can be any one you want, but this is going to be really, really, really high resolution on your screen. And you're probably not going to be able to see it if the line is too thin. So I would do something like 50 or at least 10 or 15 so that the line is wide enough that you can actually see it, because this is going to be thousands and thousands of words long. What do we do for X and Y? Well, we want to get all of the bars to be the same height because we're just trying to make a barcode. So we're just going to make Y the number 1. So no matter what the X coordinate is, the Y is always going to be 1. It's always going to be the same height. Now, if we go back and look at this chart, the X can be a single X, or it can be a list of X's. And that's why we created our dictionary, which created our different indexes. So we're going to want to have an index number there. Okay, so where do we get these index numbers from? Well, if the top, if the top 5 word, I changed this to top word because I want to distinguish it from the word in the dictionary. So we want to go through every word in the top 5, and then we want to go through every word and index in the dictionary. And if the word from the dictionary is identical to the top word in the top 5, then we want to create that plot. And the index, you see, will come from here. So I'm just going to say that again, because I think I may have got that a bit out of order. We're going to create the figure, just a blank palette. We're going to go through every word in our top 5. We're going to go through every word in our dictionary. And if that word is the same as the top word, we're going to use that information to create our bar chart. Now, I'm going to do a couple more cosmetic bits here. I'm going to make the length of the entire bar the final count, that full word count. So even if the last time that that word appears is not at the end of the book, I still want the graph to be the length of the whole book. So I'm going to use that to make the length of my X coordinates. And I'm going to take away the X ticks. I'm just going to put a blank list there because they're all going to be 1. I don't need to have numbers on the left-hand side of my screen. And I do want this to have a legend so I can see what word is what color. And I'm going to put that in the upper right of my screen. So hopefully this will all work. I'm going to show my image and then I'm going to close it so it doesn't get stuck in memory. And I do have an error. Let's see what I've done wrong. PLTY tick. Oh, Y ticks. That is just a typo. Okay, so our first barcode is done. We now have a graph, and this shows us where all of these top 5 words are inside of our entire book. Unfortunately, I don't know about you, this is not the easiest graph to read. It's certainly condensed. It gives us all the information we asked it to give us. It's done a blue line for Sed and an orange line for Tom, but I can't really get my head around what's going on there. So instead of doing one graph with 5 colors on it, I'm going to do 5 graphs that are all going to be the same color. So the way to do that is to, I'm going to copy and paste this just so that we can keep the comparison. Instead of going and adding a bar after each word, I'm actually going to take this figure and I'm going to move it underneath here. And that means it creates a new figure every time it goes through a top word. And I have to move all of these as well. so that they're all within that same area. So now if I run it this time, what it's doing is that every top word, so it's making a new figure every time there is a top word. And these shouldn't have been all the way over because, there we go. So it makes one figure every time there's a top word, and these are all parts of the same figure. And for every set of data, it does that bar chart. So if I run it now, I end up with 5 different graphs of each of those words, and they give you a nice little barcode. But as you can see, I'm doing to do a lot of scrolling here, so I can actually edit that. So instead of making it 5 high, let's just make it 2 high. And now we get these nice little test strips of all of these different barcodes. So as you can see, the amount of code that I've created here is very, very small. There is only a few little bits of elements, and everything is done quite algorithmically. What do you guys think? What sort of graphs would you have created with this sort of data? Do you have any questions? What sort of comes to mind with this information? Oh, what's the meaning of these barcodes of words? Okay, I'm sorry, I didn't make that very clear. So basically, what we've told it to do is we've gone through our dictionary, and our dictionary basically has the word itself, and then it has a list of all the times that the word appeared in the book. It was word 1, it was word 7, it was word 14, it was word 100. And what we've done here is we've plotted that so that every time the word appeared, it appears as that number. So this is word 10,000, word 20,000. And so what it basically represents is the appearance of that word throughout the entire text. If you think of the X coordinate as the word number of every word in that book in order. So there's not 50,000 different words. It's 50,000 word locations within that book. It's 50,000 words long, not 50,000 different words. So if we compare just said and Tom, said is pretty much evenly throughout the book, whereas Tom really doesn't get started until you get to about here. And indeed, if I go up here and I change the width of it to 150, it makes some of those really, really thin instances a lot thicker so that you can see them a lot better. So you can see there's this huge section of the book where Tom is never mentioned. And then there's this other big gap where Tom is not mentioned again. But if you look at Wilson, there are different gaps where that name is not mentioned again. So if you wanted to look and see how frequently a character is referred to, or how a character is referred to in different parts of a book, this would be a really good way of just visually seeing how that changes over time. You can do this with any kind of word as well. For example, if you wanted to map passive words versus active voice words, if you wanted to use dialect words versus more formal English language, you could create dictionaries that would go through and look for all the slang terms to see when they show up. There's lots of different ways that you can kind of create these barcodes to show the instances of that word showing up. Exactly, yes. And Conc, the free concordance software, which I absolutely love, it kind of inspired me on how would I do this if I was using that graph. And that's absolutely the case. As I said before, there's a lot of proprietary, although AntConc is open source, God bless him. But there's a lot of software out there that will do this particular graph. But you have to remember that before Anthony had AntConc, he would have had to have done these things manually. So for your particular research, if you think about what do you wish existed, this can be a really useful way of doing it. Another example I can give is One moment, sorry. So as I said before, I tried to make a different images of these newspapers that I wanted. So I was able to create graphs of my different newspapers. This is actually just a bar chart that I've taken word count data from a newspaper database and had it recreate the lengths of the different articles. And because I was doing it with Matplotlib rather than Excel, I was able to auto-generate a black and white version for the article print publication that I was doing. I was able to create a red-green colorblind version of that same image. Here we go. And I was able to create another one that was just sort of like, if you didn't have red-green color blindness, that was a little bit easier on the eyes. So there are all different sorts of iterations that you can use this for in order to create the exact graph and the exact visualization that you might want. In that case, I'm going to give you another example. I'm not going to go through it in as much detail because we don't have as much time, but just to give you another idea of what you can do with the exact same data set, the same dictionary that you've already created. What I did in this one is I went through the entire dictionary and I separated it into sections. So instead of having it be all the words across all of the entire book, I did 5 separate lists, 5 separate dictionaries, one for the first 10,000 words, one for the second 10,000, and so on and so on. And then I created a scatter graph where the Y coordinate was the word Wilson and the X coordinate was the word Tom. And the graph that it produces in the end gives you sort of an idea of, let's see here. Of what it looks like. And what it basically creates is in the beginning of the book, these 2 blue dots, Tom does not appear very frequently, but Wilson does. In the middle of the book, there's both of them appearing very high. And at the end of the book, they appear a little bit, that Tom appears more often than Wilson, or sorry, they both appear very little and they both appear a lot. Because this graph is a little bit ambiguous, I probably would have separated it into 6 different sections rather than just beginning, middle, and end. But these are the beginnings of what are called word vectors. And what you would normally do is, instead of doing different parts of the same book sort of arbitrarily at 10,000 words, you might do different chapters, or you might do 2 novels by the same author. And all the graph does basically is looks at a word and another word and compares the frequency of those 2 words in that text. And the idea behind word vectors is that 2 texts of the same author or the same genre will use the same words in sort of the same proportion. So what you would do is you would go through every single pair of words that exist in these 2 books, and you would measure how closely these 2 words are related to each other. Are they usually far apart? Are they usually quite similar? Again, that's not something you would want to do manually, because that would be hundreds of thousands of individual graphs. But with Python, you can actually have it measure the distance between these points as a straight line, the Euclidean distance, and then create averages. So on average, 2 books that we have labeled as romantic have a very similar set of words. Or you could just take a whole bunch of books that you know are written by Shakespeare, stick in a play that you don't know the author to, and see how likely it is that it was also written by Shakespeare, based on the amount of same word choice that is used in the same frequency. This is a whole field of research. It's really interesting. But again, it's something that you don't have to go out and buy an expensive piece of software to do. You can actually create this stuff yourself. So I'm going to leave it there for today. I hope that was useful to you guys. And I hope you have a lovely afternoon.